Welcome to Robinson Foundry. My name is Seth Robinson, and in this video, I'll be turning this clever 3D printed measuring cube into solid bronze using the Lost PLA method. I found this cool measuring cube model online, and I thought it would make for a really great casting. However, I knew it would be a challenge. Take a look at this cross section. The thinnest sections are only 80 thousandths of an inch thick, or 2 millimeters. Thin sections can be difficult to cast because the thinner the part is, the less heat the molten metal can retain, causing it to solidify before the mold is completely filled. I started this project by 3D printing the measuring cube using a plastic called PLA. PLA works great for this casting process because of its relatively low melting point and ability to be burned away without leaving any ash behind. I also printed this sprue, which will act as a funnel, helping me to pour the metal into the mold. I glued the sprue and measuring cube together using hot glue, and then glued on some pieces of PLA filament to act as vents. This stuff is called suspendoslurry. It's essentially a liquid ceramic that is used to create strong ceramic shell molds for metal casting. After filling in the text with a brush, I carefully dip the model into the slurry, doing my best to avoid trapping air bubbles on the surface of the model. The first few coats are the most important, as this is where the fine detail is captured. My goal was to slowly build up a thick shell by coating the model with slurry about 10 times. After the first two coats, I sprinkled each subsequent coat with silica sand and allowed it to dry before adding another. Normally after the fourth coat, I wrap the entire shell with thin wire, which helps reinforce the shell, preventing it from cracking. However, I didn't do that this time because the measuring cube is a very odd shape, making it very difficult to properly wrap. I allowed the shell to fully dry for a few days, and then placed it in my kiln to burn away the plastic and turn the shell into ceramic. I turned on the kiln, and over the next few hours, I slowly brought up the temperature to about 500 degrees Fahrenheit, which is the temperature at which the PLA plastic starts to melt out of the shell. At this point, I was able to remove the vast majority of the plastic instead of just burning it away. Then I cranked up the temperature to around 1500 degrees Fahrenheit. This vitrified the shell, turning it into a ceramic that can withstand the temperature of molten bronze. With the shells ready to be filled with metal, it was time to fire up my homemade cake furnace and melt some bronze. For this casting, I used some bronze that I had left over from previous projects. This bronze alloy contains roughly 90% copper and 10% tin. It took about 30 minutes to melt this amount. By the way, if you're interested in checking out any of the products used in this video, I'll include affiliate links to most of them in the description. Once the metal was melted, I added a small piece of aluminum to add strength and improve the corrosion resistance of the bronze alloy. I let the bronze heat up to about 2200 degrees Fahrenheit to make sure that it was liquid enough to fill the thin walls of the mold. Then I removed the shell from the kiln and poured in the metal as quickly as possible. I couldn't resist throwing a couple ice cubes on the metal to watch them disappear. Then I carefully submerged the mold in water for a while to cool it down. Unfortunately, this does nothing to soften the shell, but it does help cut down on the amount of dust produced when the shell is broken off. Then I started to chip off the shell with a hammer, but because of the shape of the casting, I hardly got any of it off. Removing these shells can be really difficult, especially if there are a lot of indentations on castings like this one. Fortunately, I have a sandblaster, which made the job a lot easier, but it still took about 2 hours to remove all of it. After removing the shell, I was happy to see that the mold filled out properly and the casting looked good. Next, I snipped off the vents and used a hacksaw to remove the sprue. Then, using my large disc sander, I carefully sanded the bottom smooth. I actually had a hard time polishing this measuring cube, as the little pockets made it very difficult to use anything other than wire brushes, and even then, I still had a hard time reaching certain areas. Well, here it is. I'm really happy with how this turned out. I was a little apprehensive to try and cast this cube because of the thin walls I mentioned, but I'm glad I tried because it ended up looking great. I love using ceramic slurry to cast objects like this. Look at how much detail was captured. You can see all the individual layer lines from the printing process. The casting's not without its flaws. You can see that the surface finish is poor in some areas, which I believe is from adding the small amount of aluminum to the bronze. But I still think it turned out great, and I'm glad I tried. I hope you enjoyed watching this video, and if you did, please give it a thumbs up. Tell me what you think in the comments, subscribe for future projects, and take a look at some of my other videos. Thanks for watching.